Hello, this is Miraj Patel, and today we're going to be continuing Unit 12, which is all about solutions and equilibrium, and today we're going to be talking about concentration of solutions, and then we're going to also be talking about dilutions. And so here we have the first PowerPoint, which is all going to be about concentration, and we're going to learn some calculations with concentration or molarity of solutions. And so concentration is the relative amount of solute dissolved per given amount of solvent. So this is a ratio of solute to solvent, just like this. And so I'm sure most of you have heard of concentrated like orange juice and like some stuff like that. And so if something is very concentrated, it has a lot of solute molecules per given amount of solvent. So if we have a lot of solute per solvent, that means it's very concentrated. And then the opposite is dilute, which is like right over here. We have more solvent relative for the solute molecules. And so we're going to figure out concentration of these four test tubes. And so here we're just going to use these dots as solute. So we're going to use the dots as a solute number and these little hash marks as solvents. So here we have 4 dots of solute. So 4 over 8 lines of solvent molecules. So this would be a ratio, look at the formula, solute over solvent. So 4 over 8, which would be a concentration of 1/2 for this scenario. Then we go to test tube 2, and it has 4 dots for 4 hash marks. So the solute to solvent ratio is 4 to 4 or 1 to 1. And so this is definitely more concentrated than this one because look at how much water we have in both of these, and they both have the same number of solute molecules. So because this one has more water, it's less concentrated. And then we have test tube 3, which has 8 dots, and we have 8 hash marks, just like 1. And so the ratio of solute to solvent is 8 to 8, or 1 again. So technically 2 and 3 have the same concentration, even though they have a different amount of water and solvent. So remember that concentration is a ratio of solute to solvent. So because the ratio, it has to just keep the ratio to be the same concentration. Then we have test tube 4 here, which has 8 dots and 4 lines. So solute, there's 8 over solvent, which is 4. And so 8 over 4 is 2. So this one is very concentrated. And then this one has the least concentration. And these two are just in the middle. So this one's dilute because least concentration. This one is very concentrated because there's a lot of solute per solvent. And then these two are in the middle. And so this one has a smaller concentration than this one because that's why it's less than. Then we have these two have equal concentration, and all of these have a smaller concentration than test tube 4. So that's how we get these little signs. Because it all has to do with how many little solute molecules we have per given amount of solvent. So for this one, because the concentration of 1/2, for every one solute molecule, we have 2 hashes of water. But for this one here, remember the concentration was 2, 8 over 4. So for every one line of water, there's 2 of these. So that's way concentrated. And then these two here, for every one line of water, they have 1 solute molecule. So that's how concentration is measured. And so molarity is a measure of concentration, and the formula is moles of solute per liters of solution. And usually it's measured with 1 liter of solution at the bottom. So molarity is moles of solute for 1 liter of solution usually. So there's several ways you can write molarity. You can write as 3mHCl, so the capital M stands for molarity, or 3 molar HCl, or sometimes you can write it as 3 moles of HCl over 1 liter. And so that's what I'm talking about. Molarity is usually measured with 1 liter of solution, how many moles go in, like this. So then here we're going to briefly talk about preparing a solution. So pretty much to make a 0.5 molar solution, you just add 0.5 moles of solute to a flask like this. And then we add, or we dissolve it first, and then we fill it up with water so it has exactly 1 liter of solution. So pretty much we add 0.5 moles to 1 liter of water or solvent and stir it like this. And then now we're going to do some calculations. So here's some math. And so the good thing is that this is just like what we've been learning about, like conversion. So if you remember stoichiometry, it's going to look very similar. But now we have molarity we can use for our equations. So here we have a question. So what is the molarity of a solution containing 0.9 grams of NaCl in 100 milliliters of solution? So we first have to figure out what we have. So we have grams or mass, and we have milliliters, which we can convert to liters, and we want to find molarity. So if you remember the formula for molarity, which is moles over liters, we have to first convert this to moles. We're going to start by doing that. So remember, to convert from grams to moles, we use molar mass, which we get from the periodic table. Sounds familiar, right? And so remember, when we use these fractions, whatever's on the top of this first fraction goes on the bottom of the next. And molar mass is always with 1 mole, so 1 mole goes on the top, and grams would go on the bottom. So we get the molar mass by adding the atomic masses of sodium and chlorine, and that is about 58.44 grams. So we just divide 0.9 by 58.44, and we get 0.015 moles of NaCl. So this amount of grams is this number of moles. So we have moles. So step 1 check. Now we need liters. And so we can convert 100 milliliters into liters just by moving the decimal place. So remember from way back when, at like the beginning of chemistry, we learned converting from milliliters to liters. So milliliters is 1,000th of a liter. So we just move the decimal place 1, 2, 3 places to the left, and we get liters. And so once we get liters, we can do moles over liters, and then if we do this, we can get molarity. And so this was what I was talking about when you just convert from milliliters to liters. You just move the decimal places 3 places to the left. And then opposite is from liters to milliliters. You move it 3 places to the right. So when we do these problems, you usually convert milliliters immediately to liters, just ASAP. So because it makes it so much easier to just do these problems, because you have to do it eventually. So now we have a second question, which is similar. What is the molarity of a solution with the volume of 2 liters containing 36.0 grams of glucose? So here we have grams again, which we can convert to moles using molar mass. And then we have liters, which is what we need. So we need to put moles over liters. And so first we have to find number of moles this is. So we take that number and use molar mass. And because grams is on the top, we need grams on the bottom. And 1 mole is on the top because it's molar mass. Molar mass always has 1 mole. And we calculate from the periodic table. And so pretty much we just divide by grams again, and then we get moles because we're left with it here. And so we turn out to get 0.2 moles of glucose, which is 36 grams. And so now we have moles and liters, so we can just go ahead and divide moles by liters. And if we do 0.2 divided by 2, we will get a 0.1 molarity or concentration of this. And so now we're going to be doing something different. So instead of finding molarity, we're going to find moles if we have volume and molarity. So how many moles of solute are in 3.8 liters of 0.7 molar NaClO or bleach? So this time, instead of starting with grams and converting to molar mass and stuff like that, we start out with liters. So whenever we have these problems, whatever is given to us by itself, like liters, moles, grams, we have to start with that, and we work our way towards moles. And so here we start out with 3.8 liters, and this time we use molarity to multiply with liters to find moles. So molarity is moles over liter, and so we want liters to cancel out, so we're going to write liters on the bottom. So we write 1 liter when we're dealing with molarity, and we write 0.7 on the top because this is saying that we have 0.7 moles per 1 liter of solution or bleach here in this case. So we write 1 liter on the bottom, so again, whatever's on the top goes on the bottom. It stays true with molarity. And we write 0.7 on the top because we're just saying that there's 0.7 moles per 1 liter. So liters would cancel out, and so we pretty much do 3.8 times 0.7, and we get 2.66 moles of bleach. So remember, when you're doing these conversions, whatever's on the top goes on the bottom of the next fraction, no matter what it is. Even molarity follows the same rule. And when we write this, molarity, always write 1 liter with 0.7 or whatever the molarity is. Just like molar mass. Molar mass has the same thing. There's always 1 mole and X amount of grams. And the same thing here. 1 liter, and then this tells you how many moles there are in 1 liter. And then now we're going to do another problem with finding moles. So how many moles of solute are in 250 milliliters of 2.2 molar of CaCl2? So again, we start with the same thing, but instead of having in milliliters, we want to convert to liters so we can cancel out when we do molarity. So we can move the decimal place 3 spaces to the left to convert to liters. And again, liters we want to cancel out because we want to go to moles. We don't want to stay in liters. So we write liters on the bottom. And again, this tells you how many moles goes on the top. And then we always write 1 liter when we're doing molarity. And so liters cancels out. We would do 0.25 times 2.2. And if we do that, we just get 0.55 moles of CaCl2. So this tells you how many moles you need with 250 milliliters to make this concentration. So if you wanted to check your stuff, you could have done this moles divided by 0.25 liters, and if you get the same exact concentration, you're correct. And so that's a good check step if you want to make sure you're correct. And so now we're going to be finding mass or grams from molarity and a quantity. So this is just like what we've been doing on the last one, but instead we want to go an extra step and use moles to grams. And so what is the mass of sodium hydroxide, NaOH, that is needed to make 200 milliliters of a 0.15 molarity solution? And so we start out with what we have. So we have 200 milliliters, and again convert to liters because molarity is in liters, so we want it in the same unit. So immediately just convert it. So it's 0.2 liters, and liters goes on the bottom of the next fraction because we want them to cancel out. Remember, molarity is always written with 1 liter and X amount of moles, and the moles is right here. So we have 0.15 moles for 1 liter. So liters cancels out, we're just left in moles. So 0.2 times 0.15 gives you 0.03 moles of NaOH. And so once we have moles, how can we convert to grams? And if you go back and think about stoichiometry, we use molar mass to convert from moles to grams. So now we go back to what we've already know. So we do 0.03 moles of NaOH, and then we use molar mass, and again, moles once it cancels out, so moles goes on the bottom, 1 mole always in molar mass, X amount of grams on the top, so 0.03 moles times 40 grams, and then this gives you the gram amount, and we need 1.2 grams of NaOH with 200 milliliters to make a 0.15 solution. And so, um, if you want to check, you could convert this to moles. So pretty much just work backwards to this answer, and then we could divide 0.03 by 200, or 0.2 liters, because this is milliliter, we're going to convert to liters, so moles divided by liter, and we should get this concentration, if you wanted to check. And then here's the last part, finding volume. So how many liters of 1.15 molar solution are needed to give 0.805 moles of solute? So here we have, so again, we just start out with what we have. So we start out with moles, but this time we want to find how much liters we need with this amount of moles to get this concentration. So instead of putting liters at the bottom, we put moles on the bottom so moles can cancel out this time. So moles is on the top of this fraction, so moles is on the bottom, and its molarity tells you how many moles we have per liter. So instead of liters on the bottom like we normally were doing, liters on the top this time, so we're left with liters, moles cancels out. So we do 0.805 divided by 1.15, and we get 0.7 liters of solution for this many moles. And so if we want to convert this to milliliters, or how many milliliters we needed, we can just move the decimal place again 3 places instead to the right this time, and we get how many milliliters we need. And so for these problems, always make sure to set up the fractions correctly. So we always start with what we have, and it's usually liters, moles, grams, whatever it is, and then we usually use molarity or molar mass to convert to moles. And always remember, whatever's on the top of the first fraction goes on the bottom of the next. And for molarity and molar mass, there's always 1 mole or 1 liter with X amount of moles or X amount of grams, respectively. For molar mass, it's grams. Molarity, it's moles. And then from moles, you can go back to grams or, to moles and molarity. And so now we're going to be talking about dilutions, which is honestly much more simpler than any calculation we've done, because basically just multiplication. And so dilutions, first of all, are when you lower the concentration or molarity of substance. So pretty much we do this by adding more of the solvent. So here we have 6 moles of solute with 100 milliliters, but then we have 6 moles with 200 milliliters. So we just added twice as many solvent. And so because we increased the denominator, or we divided by a larger number, we decrease the molarity. So we pretty much decrease molarity by increasing the denominator in the formula. Because 6 divided by 100 is only is a smaller number than 6 divided by 200. So that's what we did. And so we have some calculations we can do with this. And here's a formula. So molarity, initial molarity times initial volume equals molarity of diluted solution times volume of diluted solution. So you can think of m sub 1 times v sub 1 equals m sub 2 times v sub 2. So these are always equal. So pretty much we just plug in everything and then solve for the unknown variable that we have, and it could be any of these. So here we're going to be first finding volume if we have everything else. So how many milliliters of 2 molar MgSO4 must be diluted to prepare 100 milliliters of 0.4 molar MgSO4. So here, this is the more, so we have to first figure out what we have, and so this is the more concentrated solution. So this is M1 because it's more concentrated, and then these two are grouped together because this is a diluted solution. So this is V2 because the volume of the second one here, and then this is also M2 because it's the more diluted version. So we group them together and plug them in the formula, and it's always important. So we have V1 here, and that's what we're going to solve for. And I like to call it X, so instead of calling V1, I just call it X. And at the very end, I just know what to solve for, but you can just leave it as a variable if you want. And so we just plug in everything. So M1 goes right here on the first one, and then V1 is X, so we just leave that as it is. Then we do 0.4 molarity, which is from right here, M2, times V2, which is 100. And so, to solve for X here, we have to move or divide by molarity, because just think of simple algebra. We have to undo this, so you divide by 2, divide by other side by 2, and we're left with V, so we're solve for X. And we just complete the operation, so we do the product of 0.4 times 100 and divide by 2, and we would get the answer of 20 milliliters. And it's always important when you're doing these calculations, you always keep volume the same. So if volume is in milliliters here, this answer will be in milliliters. If this was liters, this answer would be in liters. And molarity is always the same because molarity is always written with moles of solute per 1 liter. So that's fine, but always keep volume in the same unit. And then here, now we're going to do finding molarity if we have everything else. So 200 milliliters of 10 molarity or molar solution is diluted to 500 milliliters. And so what is the molarity of the diluted solution? So here we have V1 here because this is volume of the first one. Then we have M1 right there, which is molarity of the first one. So whenever we have these word problems, usually the two that are grouped together are like literally right next to each other. And then we have a dilute solution, so this is V2 because volume of the second one. And then we're solving for M2, the molarity of the second one. So we plug these all in, and so M2 is going to be our X in this case. And then here we have everything plugged in, so we're all ready to solve. So in order to solve for M2, we have to isolate it. So think of algebra. This is being multiplied with 500, so we divide by 500 on both sides. So you do 10 times 200 divided by 500, and that's how we get M or X. And X is all by itself. So there's how you solve it. And so if we type this in a calculator, and we would get a molarity of 4 as our answer. And so that is the last question for today. And so pretty much when you're doing these problems, make sure we go to the word problem and figure out and label everything, and then we plug them in, and it's always a one-step division problem that happens in this in these dilution problems. And so I hope this helped you. And always remember, when you're doing these math problems, you just got to keep practicing and know how to set it up. And if you know how to set it up, you'll do perfectly fine. And so, so the next video is going to be all about solution stoichiometry, and then we're going to be talking about equilibrium of solutions. And so, I'll see you next time, and I hope you have a good day.